All right, I'm back. We're still on page 280. We just finished this problem. I want to go back up and just remind you, because we talked about it at the beginning of the last problem, but then it didn't even come up on the last problem, that this notation right here is telling you that both Q and R are in between -6 and 5 because it's parentheses, it's exclusive. If it was brackets, right, with right angles, it would mean inclusive. So that's just notation that we're going to need a lot in this problem. So let's see if we can do it. All right, sketch a function satisfying the following conditions. Just like last time, we like cold hard facts. So anything that we can deal with and just plot immediately, that's what we'll go for. F of -4 is -2. Awesome, cold hard fact. For all a and b in between -5 and -3, what? F of b minus f of a over b minus a is equal to 3. So that probably looks familiar, right? Because this is telling me that's the slope. So it's telling me the slope is always 3. So what kind of thing has a slope that's always 3? It's a line, right? So it's going to have to be a line in between -5 and -3. Furthermore, if you look back at the first piece of information, -4 is between -5 and -3. So we know one point on the line, and we know the slope of the line. So that's going to be a good start. The limit as x approaches -3 of f of x exists. That's good if I know the limit from the left or the limit from the right, because I know they have to be equal. So I can kind of like use that. F is not continuous at -3. Useless. I mean, not useless, but like it tells us whatever the limit is, the value of the function is not that. So that'll be something to consider. For all c and d that are in between -3 and -1, another slope formula, the slope will be -2. So this is also slope. So let's also slope. F is continuous at x equals -1. Good, because if we knew the limit from the left or the right, that would tell us the value of the function. So that's good. For all k in between -1 and 2, the limit as k approaches f of x is equal to L. So what kind of thing on an entire interval from -1 to 2 would have the exact same limit at every single x value? Think about that for a second. So the limit as x approaches -0.9 is equal to some number. The limit as x approaches -0.8 is equal to the same number. The limit as x approaches -0.7 is the same number. It's got to be a horizontal line. This is basically telling us all of this is telling us that the function must be horizontal there. So that's good to know. The limit as x approaches 2 of f of x doesn't exist. Who knows? I mean, limit from the left doesn't equal the limit from the right. That's all we really know. But this confusing thing is true. L, the absolute value of L minus f of 2 is equal to 3. So whatever the limit is at 2, because 2, so this is L, right? Whatever the limit, and that'll tell, the limit from the left at 2 is going to be whatever L is. And then the absolute value of L minus f of 2 is equal to 3. We'll deal with that when we get there. And then the limit as x approaches 5 of f of x is -2. That's like the next most concrete thing we were given. Like we could actually pencil that in if we wanted to. All right, let's see. Let's just start with some axes. I'm gonna go from negative like 6-ish to like, I gotta go to like 6. -6 to 6, I think. And I'll put 0 in the middle, which I really hate doing, but like, I don't know what's going on here. So 6, 4, 6, 2, seems right. I don't know. -6, -4, -2. Some extra tick marks. All right, let's see. First piece of information is that f of -4 is -2. It's all going to be wishy-washy from there. So let's do that first. -1, -2. All right, f of -4 is -2. Check. All right, and then we said this next piece of information is telling us that we basically have a linear function with a slope of 3. I know that it goes through -4, -2. So if I go over 1, I have to go up 3. So that would put me here. And I don't know what to do with that, so I'm going to put an open circle. Anytime you're in doubt, put an open circle and you can like work it out later. And then if I go back 1, I have to go down 3. So it's -5, and then back 1. So let's say here. And I know that in between, any 2 points in between, if I find the slope, I have to get 3. So it's a straight line. It's a perfectly straight line. So I've done, so that was actually, should have highlighted it. That was this piece of information, and I think we just dealt with that. So we made sure that the slope between any 2 points between -5 and -3 will always give you 3. That works. All right. The limit as x approaches 3, -3 exists. All right. Well, I know the limit from the left is +1. So the limit from the right is also +1. So the limit from the right is +1. And now let's see. So like I know that. Let me just. So this piece of information. It's hard to like keep track of everything you know, right? So I know that the limit as x approaches -3 of f of x must be 1, right? And I know that because the limit from the left is 1, so the limit from the right must be 1 if the limit exists. I also know the function is not continuous at -3. I don't know that that's telling me anything right now, like nothing in particular. But look at the next piece of information. So I think, have I used this yet? Not exactly. I think I'm going to check this off. We're going to check off 2 things at once, I think. This piece of information is that for any, so the limit needs to exist at -3. And for any points between -3 and -1, the slope is always -2, which means that it's just a linear function between -3 and -1. So if the limit has to exist, then I must have to start at -1, 1 with the open circle. And then if I go over 1, I'll go down 2. So let me do that. Over 1, down 2 puts me here. And then it's until -1. So if I go over 1, I'll go down 2 again. So that's 1, that'll be -3. I don't know what to do there, so I'm just gonna like open circle it. Let me fill this in. All right, does this fit the bill? So the limit as x approaches -3 exists. Got it. F is not continuous at -3. I didn't fill in the point, so yeah, that's true. So we got that. The slope between -3 and -1, for any 2 points, the slope will always be -2. That works, so we got it. All right. F is continuous at x equals -1. All right, good. If f is continuous at x equals -1, that means the limit from the left equals the value of the function. So I can fill in this circle. That's why you always go open circle until you know more. So this can be filled in. So I only half used that information so far, but let me, I'm running out of colors. Not running out of colors, I just like can't tell which ones I've used. I definitely didn't use this one yet. Ooh, I got close to using it though. So we like half use that because I didn't use the limit from the right being equal to -3 yet, but it's gonna have to be. So for everything between -1 and, so f is continuous, which means that f of -1 is definitely equal to -3. And then the limit between -1 and 2 is always the same thing. We said that means it's a horizontal line. So if that's going to be true, because the function is continuous, the limit from the right has to be equal to -3. I think what we can do is go straight across here. And then I don't know what to do here, so I'll open circle that. But I think now we've used that, the fact that it's continuous. And then here, I think we just use this. So I think we're done with that. I accidentally changed this pen. Okay, I think we did that. I don't know why I checked off this before. I think I checked that off when I decided it was horizontal, maybe. I don't know. It's really unclear to me why that's checked off. All right, the limit as x approaches 2 doesn't exist. All right, so that means the limit from the right is not equal to 2. but the absolute value of the difference between L, so L we now know is -3. So we've worked out that this is -3. Specifically because the function's continuous at x equals -1. That's how we work that out. If the limit didn't exist at -1, then that could have been like anywhere, and we could have just gone from there. But since your continuous at -1, it had to be -3. All right. This is just telling me the distance between -3 and f of 2 is 3. So maybe I should write that somewhere. So there, the distance between -3 and whatever f of 2 is 3. So f of 2, so this is weird. F of 2 is either 0, which is 3 units away from -3, or f of 2 is -6. We don't have enough information to decide, so I feel like at this point it becomes like a choose your own adventure. So I'm going to say that in some instance, that would put me here. Okay. And then, so that's f of 2. What else do I know? The limit doesn't exist. Good, done. Let me highlight and check things. Limit doesn't exist, but this. All right, I would say, so let me fill in the other dot. That's -3, 4, 5, -6. It's one of these. We don't know which, but that's okay. There's just ambiguity in the problem. There's actually a lot of ambiguity in the problem. I'm just doing like the things that must be true. So far, this graph is everything that must be true. And there's actually no deviation on this one. Like your graph needs to look exactly like this. There's not a lot of options because everything has to be linear, basically. Limit as x approaches 5 is -2. Okay, but we don't know the value of the function, so that's an open circle situation. So the limit will be -2. All right, let's go for it. So, and that's all we know. That's weird. Okay, here, but that I need that to be the limit. So like I need from the left and the right. So like maybe this. I don't know. Or maybe this. Like no way to know. There's not enough information to decide anything else. But I think that we're done. I think that's it. Wrong color. Ruined the whole motif. Gone. All right, there. I think we're done. I don't think there's anything else you can do. So a lot of information, but if you follow it piece by piece, find the most definitive things, right? Like actual points that are on the graph, fill those in. Actual limits that exist, fill those in with open circles until you know if you should be filling them in or not based on other information. And if you follow that and you got your limits down, you got your notation down, I think you'll be okay. These problems are, as I mentioned, like way up above, they're kind of just like puzzles, and you just like work through it a piece at a time, and eventually you just have your graph, and you're like, yeah, that's pretty good. All right, so I'm gonna cut this here, and obviously I'll be back with more in the next video. So see you then.